Space, an endless mysterious expanse that stretches beyond imagination. It's easy to feel small when you think about it. But even as we attempt to grasp the vastness of the universe, we realize how little we truly know about it. Hello, my name is Lily, and today I invite you to a cosmic journey. From the stars that light up the night sky, to the black holes that hide in the dark corners of space, there is always something new to learn.
Somewhere here in the universe lies our solar system, where Earth orbits a star we call the Sun. Like billions of others, this star is a part of the Milky Way galaxy, a spiral that contains around 100 billion stars, with planets and moons revolving around many of them. But the Milky Way is only one galaxy in a much larger picture.
The observable universe is home to over 200 billion galaxies, each a vast collection of stars, planets, and cosmic phenomena. To grasp the scale, picture this. If every grain of sand on Earth represented a star, you'd barely hint at the observable universe's vastness.
Now, when we talk about the observable universe, we mean the part we can detect with our most advanced telescopes. This enormous expanse stretches out 93 billion light-years in every direction.
A light year, the distance light travels in 1 year, is around 9.65 trillion kilometers or around 6 trillion miles. To give you a better perspective of this mind-boggling scale, light could travel 250,000 times around Earth in just 1 day.
So the observable universe is approximately this big, and what lies beyond remains a mystery, shrouded in the unknown.
But we know something about stars, basic units of galaxies. They come in all sizes and colors, ranging from the enormous hot blue giants to the cooler, dimmer red dwarfs.
Our own sun is a middle-of-the-road yellow dwarf, but it's the very reason life exists here on Earth. Stars aren't just burning balls of gas. They are factories where the elements that make up the universe are created. Through nuclear fusion, stars convert hydrogen into heavier elements like carbon, oxygen, and nitrogen, elements crucial for life. Without stars, there would be no planets, no life, no us.
But stars don't last forever. The most massive stars burn out quickly, living just a few million years before collapsing into black holes or exploding in supernovae. Our Sun, however, is only halfway through its 10 billion year life. In about 5 billion years, it will expand into a red giant and eventually shred its outer layers, leaving behind a white dwarf. Even though our Sun's story is relatively short compared to some of the universe's longest-living stars, it's part of an endless cycle of birth, life, and death that defines the universe.
Beyond our galaxy, there are others, immense collections of stars bound together by gravity. In fact, the universe is filled with galaxies of all shapes and sizes. Spiral galaxies like ours, elliptical galaxies, and irregular ones. Some of those are even merging. In about 4 billion years, the Milky Way is set to collide with Andromeda, and together they will form a completely new galaxy. It's a reminder that the universe is constantly changing and evolving. Nothing is truly static.
One of the most fascinating phenomena in space is the existence of black holes. These cosmic giants have such intense gravity that nothing, not even light, can escape their grasp.
Black holes form when massive stars collapse under their own weight, creating an incredibly dense point of matter known as singularity. Surrounding the singularity is the event horizon, the point of no return. Once something crosses this threshold, it's lost forever.
Despite their seemingly destructive nature, black holes actually play a crucial role in the cosmos. They help regulate the growth of galaxies and the formation of stars. In fact, our Milky Way has a supermassive black hole at its center, known as Sagittarius A. It's about 4 million times more massive than our Sun.
Even with all our advancements, there are still significant mysteries that remain unsolved. One of the biggest puzzles in the universe is the nature of dark matter. Although we can't see it or touch it, we know it exists because of its gravitational effects on galaxies and other celestial bodies. Dark matter makes up about 27% of the universe's total mass. And then there is dark energy, a mysterious force that's driving the accelerated expansion of the universe. Together, dark matter and dark energy account for around 95% of the universe's total mass energy content. Yet, we still don't fully understand what they are. It's like we're working with a cosmic jigsaw puzzle, but most of the pieces are missing.
When we look back at the origin of everything, the Big Bang Theory stands as our best explanation for how the universe began. About 13.8 billion years ago, the universe began as an infinitely small, hot and dense point.
Then in a split second it expanded rapidly and cooled down. Matter began to clamp together, forming stars, galaxies and eventually planets. The Big Bang didn't just mark the birth of the universe, it set in motion the processes that continue to shape everything we see today. One of the most valuable pieces of evidence we have for the Big Bang is the cosmic microwave background radiation. This faint glow is the residual heat from the early universe, providing a snapshot of the cosmos when it was just 380,000 years old. Studying this radiation has given scientists crucial insights into the early conditions of the universe, its composition, and its ultimate fate.
Space is more than just a place we look up at. It's a living entity, constantly changing, evolving, and expanding. With each discovery, we come to understand just a little bit more about vast cosmos. But even as we learn more, we're faced with new questions and new mysteries. At the core of our understanding of the universe is the concept of space-time. Introduced by Albert Einstein in his theory of general relativity, space-time is the fabric that underpins everything we know about the cosmos.
Massive objects like stars and planets warp this fabric, creating the force we experience as gravity. Space-time is a four-dimensional continuum, where the three dimensions of space are twisted together with time. This revolutionary concept fundamentally changed the way we view gravity, offering insights into phenomena like black holes, the bending of light near massive objects, and the expansion of the universe. Einstein's theory also suggests the possibility of wormholes, hypothetical tunnels that could connect distant points in space-time. These wormholes could, in theory, allow faster than light travel or even time travel.
While they are still speculative and would require exotic matter to stabilize them, the idea of hopping through time or skipping across the galaxy in an instant is an intriguing one. Maybe one day we will find a way to travel through them, or at least find a shortcut to the future where we have a little bit more answers about our world. Could our universe be just one of many in vast multiverse? The idea seems almost fantastical, yet it's rooted in cutting-edge theories like cosmic inflation and string theory.
According to the multiverse hypothesis, our universe could be just one bubble in an endless sea of universes, each with its own unique set of physical laws and constants. The notion may sound like science fiction, but it could potentially explain why the conditions in our universe are so perfectly tuned for life. After all, if there are infinite universes, it's no surprise that we exist in one where the laws of physics enable the emergence of life.
In this multiverse model, the variety of universes could span unimaginable differences. Perhaps in one, the laws of physics are completely different, and the building blocks of life are radically altered. Or maybe there's a universe where dinosaurs never went extinct and evolved into intelligent, coffee-drinking beings.
While still highly speculative, the multiverse remains one of the most exciting and mind-bending possibilities in modern physics. Whether we'll ever be able to confirm its existence remains uncertain, but the idea of parallel universes opens up endless avenues for exploration. And who knows, maybe some alien civilizations are out there, considering whether we're just a small blip in a much bigger cosmic landscape.
The question of whether we are alone in the universe has fascinated humanity for millennia. As we continue to search the stars, the possibilities are endless.
Our focus has been on planets and moons in our solar system. Mars, the icy moons of Jupiter and Saturn, where the conditions might allow life to exist. Additionally, scientists are listening for signals from extraterrestrial civilizations, hoping to catch a glimpse of life beyond Earth. The discovery of even the simplest forms of life in another world would fundamentally change our understanding of biology and our place in the universe.
With the rapid advancement of technology and the discovery of exoplanets in the habitable zones around the distant stars, we might be closer than ever to answering the age-old question: are we alone?
The universe we can observe is about 93 billion light-years across, but it's just the tip of the cosmic iceberg. Beyond this observable limit, the universe may continue infinitely, or perhaps it loops back on itself in a higher dimensional space. This question, what lies beyond the observable universe, has captivated cosmologists for decades. Is the universe infinite, stretching far beyond what we can see? And what happens beyond its edge? Is it just empty space, or does the cosmos continue in a different form we can't yet comprehend? It's a mystery that challenges everything we know about space, time, and reality itself. And perhaps that's a question we may never fully answer.
As we peer into the distant future, one of the greatest cosmic questions remains: what is the ultimate fate of the universe? Theories propose dramatic endings.
The Big Crunch envisions expansion reversing, collapsing, all into a singularity. The Big Freeze sees endless expansion, stars dying, and galaxies drifting into a cold, dark void. The Big Rip suggests accelerating expansion could shred galaxies, stars, and even atoms.
While these scenarios offer a dramatic conclusion to the universe's tale, there is no need to worry just yet. These events are billions of years away, far beyond our time. For now, we can just marvel at the cosmic show unfolding around us and cross our fingers for a happy ending. One where the universe continues to surprise and delight us, generation after generation. Thank you for your time. See you in the next video.